Hi, this video explains naive-Bayes classifier which is based on Bayesian theorem which is called Bayesian algorithm method. The naive-Bayes denotes the occurrence of certain features is independent of occurrence of other features. So a feature is independent of another feature in the given data set, which is primarily used in text classification that includes high dimensional training data set. The naive Bayes will assume two cases. One is each feature is independent of another feature and each feature is contributing to the solution equally. So each feature is having equal contribution. So these two assumption to be uh, assumed to be given to the naive Bayes classifier. The naive Bayes classifier is called probabilistic classifier, which is applied to each sample x, which is described by conjunction of attribute values. For example, if I have the data set x1 feature, x2 feature, x1 feature and x2 feature, x3 feature, then we will have the actual label. So which is stated as conjunction of all the attribute values, where the label target function, the label is called f of x, can take on any value from some finite set of target values capital Y. The target values in the sense it may have yes, no, yes, like that. So the finite set of target values. So here we are having the finite set of target values. It will select any one value from the finite set of target values. A set of training samples of given target function and a new instance is new test data. The test data is described by the tuple of attribute values. That means suppose if I am going to give the samples will be 1 2 3. So this entire row is called tuple. So each sample is described in the form of tuple. That may be a sample data, training data or test data. All the data are described in the form of tuples. So here a1, a2, an. So here the a1 is feature 1, a2 is feature 2, etc. a3 n. Okay, an is nth attribute or nth feature. Then f of x is the target function. The learner, the naive Bayes classifier, predicts the classification for the new test data. This approach is assigning the most probable target value to given new test data based upon the attribute values a1, a2, an, which is assigned as capital X. So based on the Bayesian theorem, the probability of predicting the target function for the given data I, based upon the based upon the sample x for the given data x, probability of x given y, prior probability of y, and marginal probability p of probability of x. So we can rewrite this equation using the chain rule. Here each sample x is having n number of attributes a1, a2, an. In our example we are having three attributes, three features. So we can write general equation. The prediction is given by set of features, n number of features, equal to the feature probability of feature 1 given y, probability of feature 2 given y, etc., probability of feature n given y, multiplied with prior probability of target value and divided by all the probability of attributes or features. This equation can be written in the machine learning, the probability of target function y given set of features. So probability of feature 1 given target function, probability of feature 2 given target function, multiplied with probability of target function, then probability of feature 1, it's multiply with probability of feature 2, etc., probability of feature n. The denominator remains constant for a given input. That means this is same to all the data samples. So we can ignore this term. When you are ignoring that term, you will get the numerator probability of feature 1 given y multiplied with probability of feature 2 given y, etc., probability of feature n given y multiplied with prior probability of target value y. So we can say this prediction is proportional to the prior probability and product of all the features given y. So compute the probability of given set of inputs x, that is samples x, for all possible values of the class y, and choose the prediction y with maximal probability value. So to select the maximal probability value from the set of target classes y which is available in the target function can be defined as the product of all the features given the target value y and prior probability of y. So here the probability of y is prior probability for each class, and this is conditional probability. The each feature is defining the output y. Thanks for watching.